In this lecture, we are going to study about types of optical fibers. This is lecture 9 of unit 4, the chapter fiber optics. We shall see the types of optical fibers. Based on the mode of propagation, fibers are classified into single mode propagation and multi-mode propagation. Based on variation in the coarse refractive index, optical fibers are divided into a step index fiber and graded index fiber. And based on material, fibers are classified as either plastic and glass. Now we'll try and understand what is mode, because we are saying based on mode of propagation, fibers are classified into single mode propagation and multi-mode propagation. So we'll try and understand what is the meaning of these modes. The light launched into the fiber within the acceptance cone propagates through it by total internal reflection. But only light which travels through the fiber in a particular direction are allowed, which satisfy the condition of constructive interference. The light rays traveling in the specified directions are called modes. So light rays traveling in the specified directions are called as modes. Modes are specified directions along which the condition for constructive interference has been satisfied. Now, here the diagram shows what is a single mode and a multi-mode fiber. If the thickness of the fiber is small, then it supports only one mode, and the fiber is called monomode or single mode fiber. If the fiber supports more than one mode, then it is called as a multi-mode fiber. You'll see the difference between a single mode and a multi-mode. Single mode has a small core diameter and can support only one mode of propagation. The diameter is about 2 to 8 micrometer. Launching of light into the fiber is difficult. Fiber can carry information to longer distance since dispersion of signal is less. What about multimode? Has a large core diameter and can support a number of modes. The core diameter is about 50 micrometer. Launching of light into the fiber is easy. Fiber can carry information to short distance only since dispersion of signal is more. Next, we can see what is a step index and a graded index fiber. Step index fiber, in these fibers, the refractive index of core is uniform and is slightly more than that of the cladding. Intermodal dispersion or pulse broadening occurs. What about graded index fiber? In graded index multimode fiber, the refractive index of the core varies radially. It has maximum refractive index at its center, which gradually decreases with increase of radius. At the core cladding interface, the refractive index of the core and cladding are the same. Pulse broadening is overcome in graded index fiber. So this is the picture of a multimode step index fiber and a multimode graded index fiber. In step index fiber, you would say pulse broadening will occur, whereas in multimode graded index fiber, pulse broadening is not present. So see the transmission of signal in a step index fiber. Okay. Now let a pulse travel through the step index multimode fiber. The pulsed signal travels in different paths. Let us take path 1, a straight line path, and a path 2, which is a zigzag path. At the receiving end, the ray traveling along path 1, straight line path, reaches first, while the ray traveling along path 2, which is zigzag path, reaches after some time delay. Hence, the pulsed signal received at the destination is broadened and is called intermodal dispersion. Intermodal dispersion can be overcome by using a graded index fiber. So you can see this is the input signal over here and this is the output signal over here, and the output signal undergoes what is known as pulse broadening. So a step index fiber have got what is known as pulse broadening, and in this diagram, this is the core and these are the cladding part of it. Next, we can see the transmission of signal in graded index fiber. Let a signal pulse travel in two different paths. Path 1, the innermost region, path 2, the outer region. The entire thing is the core. The pulse traveling along path 1 travels less distance but in a medium of higher refractive index. Medium of higher refractive index means what happens to the velocity? Velocity will be less. The pulse traveling along path 2 travels more distance but in a medium of lesser refractive index. If the refractive index is less, speed will be more. Hence, both the pulse reach the destination at the same time and pulse broadening is overcome. This is one of the advantages of a graded index fiber to a step index fiber. In these, we can just define and see what is a meridional ray and a skew ray. A ray that propagates through the core of a fiber undergoing total internal reflection is called meridional ray. A meridional ray always crosses the fiber axis. This is the fiber axis over here. So meridional ray always crosses the fiber axis. What are skew rays? Skew rays describe angular helical path as they travel along the fiber. A skew ray does not cross the fiber axis. It just goes around the axis of the fiber. It does not cut across the axis of the fiber. So that is what is a meridional ray and a skew ray. We shall see the difference between a step index fiber and a graded index fiber. Step index fiber, refractive index of core is uniform throughout except at one stage, that is where the core meets the cladding. Single and multimode propagations exist, used for short distance applications. Attenuation losses are of the order of 100 decibels per kilometer. Meridional rays propagation takes place, easy to manufacture. What about graded index fiber? Refractive index varies gradually with radial distance in the core itself. It is a multimode fiber used for long distance applications. Attenuation losses are of the order of 10 decibels per kilometer. Skew rays propagation takes place and difficult to manufacture. These are the differences between a step index fiber and a graded index fiber. Next, we can see the classification of optical fibers based upon the material. Material of the fiber can be plastic or glass. Plastic fiber, plastic fibers are made either entirely from plastic, that is core and cladding is made up of plastic, or with silica core and plastic cladding. Full plastic fibers suffer from high attenuations. Plastic fibers are used for short distance, low bandwidth systems in the wavelength range of 600 to 700 mm. Examples of polystyrene, it can withstand temperature of about 70 degrees centigrade. What about glass? Glass fibers are made up of silica. They are used for long distance communication and can withstand temperatures of about 400 degrees centigrade. Chemical resistance is high in glass fibers. Attenuation is less. So in this particular lecture, we have seen the different types of fibers and how they are classified into various types.